What up, Algebra 2 peeps? So hopefully you've done some noticing and some wonders, and you have identified that we have some long division happening up here, right? And we have a remainder of 0 in this one, and then these ones are the continuing this process. Hopefully you noticed all these things. So this is a long division problem. And then hopefully you noticed that things are kind of mimicked down here when we see this polynomial long division. So yes, long division can be done with polynomials. And when you're doing it, sometimes there will be a remainder of 0. And if that means, if that is a factor of 0, that means that these two things are factors. These two are factors of this big long polynomial. Just like 11 and 252 are factors of 2,772. So hopefully those are the notice and wonders that you did. Now on the next page, I'm hoping that you guys were able to look at the long division problem and that you were able to get some values out of this. Hopefully you got 3x here and then 3x here, and then said, okay, I need a total of negative 7x, so that's negative 10x here, and then this would have to be a negative 5, and finally I get my, it worked out perfectly. And when it works out perfectly, you get a 0 remainder. So this is the long division problem for this problem. They equal each other. It's the same operation, just two different ways. And I'm hoping that you guys have noticed that there are some correlations between the two. Let me see if I can get a highlighter tool going on here somewhere. Hopefully you're seeing these values. Oh, that did not work out well. Let's erase that and try again. Hopefully you're seeing these values right here in your chart, but they happen to be the opposite signs. They're being subtracted. Same thing with these two, 10 and the 5. They're over here in your chart, but they're being subtracted. Okay, so you're going to see some similarities between the chart and the long division that you're doing. Okay, and then down here it says x minus 2 is a factor of this. Remember, that means your remainder is 0. And it says then to finish the division started here. So let's take some time, and I'm going to finish the division that is started there. I don't think I have enough room over there, so I'm going to copy it over here. Okay, I went ahead and copied it down, but you'll notice that mine looks a little bit different, and I want to talk about why that happens. So when you divide, you actually divide, multiply, subtract, check, bring down. Divide, multiply, subtract, check, bring down. So you divide this into this. So first term into first term. So I'm taking 2x to the third and I'm dividing it by x. Now when I get a value for that, 2x to the third being divided by x, well, that just leaves 2x squared left over. Remember, I'm asking myself, x times something is going to give me 2x to the third. So that has to be 2x squared. That's how I got this number up here. And then I multiply this value times my divisor. And that's how I got 2x to the third minus 4x squared. Then you have to subtract. So in long division, you have to divide, then multiply, then subtract the two of them. So you'll notice down here, they went ahead and switched the signs. They subtracted them, so they knew this was going to become a minus 2x to the third and a positive 4x squared. I like to keep that minus out in front and then just do the subtraction in my head. So that's going to be 2x to the third minus 2x to the third. That gives me 0. Check to make sure this part is 0. And then check to make sure that you've done this part correctly. That's negative 7x squared minus a negative. That gives me positive 4x squared. So that's negative 7x squared plus 4x squared. So that's minus 3x squared. Now, I don't really need that 0 in front. Check to make sure it happens, but you don't necessarily need it there. In fact, it might get in the way, so don't put it if you can help it. Okay, then I go back over to my problem, and I bring down the next thing. Well, that's positive x. And I'm just going to start that process over again. Divide first thing in my divisor by the first thing here. So if I'm trying to figure out something times x gives me negative 3x squared, that something would have to be negative 3x. So now I multiply the two of them together. I've divided, I'm multiplying now. Negative 3x times x is negative 3x squared. Negative 3x minus 2, that's negative times negative is positive 6x. I'm going to subtract all of it. So I'm using my parentheses to show me that I'm going to subtract all of it. And then I'm distributing that negative in my mind. So negative 3x minus a negative becomes positive, and these two things drop out. We check to make sure that that happens. And then positive x minus a positive 6x is x minus 6x, that's negative 5x. And then bring down the next thing. So this is how this works. Divide, multiply, subtract, check, bring down. Divide negative 5x by x, so something times x gives me negative 5x, that's negative 5. Multiply the divisor times what you just put up there, negative 5x plus 10, and then subtract it. Subtract all of it, so use your parentheses. Check to make sure this first thing adds to 0. Negative 5 minus a negative, that becomes negative 5 plus 5x, that becomes 0. 10 minus 10 becomes 0. My remainder is 0. So I get two factors. So this is a different way to do the same problem. And when I'm doing it, I'm going to divide, multiply, subtract, check, bring down. Okay? Can you still use the boxes? Absolutely you can. 100% you can. I would like for you to give it a try today. Try your long division. But if you can't work it out, then that's okay. So I'm going to quietly complete the next problem, and I'm going to make sure that I'm divide, multiply, subtract, check, bring down as I move along. Okay? Notice where I say quietly. I'm not going to do it quietly. Notice where I'm putting, whoops, it shouldn't be 2x, it should be 1x squared. Notice where I'm putting my result, though. I put it over the thing that it's a like term with. So, for example, when I get my result and I say 2x times something gives me 2x to the third, that something has to be x squared. I'm going to put it over the x squared term. Subtract. Check to make the first thing fell out. Bring down the next one. Divide. Multiply. Subtract. Oops, make sure you didn't screw it up along the way. Check to make sure the first thing fell out, and then bring down the next one. Divide. Subtract. Get your remainder. Now, Jada used the diagram shown here to figure out that this is true, so we already knew the answer was this. This is what it would look like if she had used long division, okay? So hopefully you can use that to your advantage as you move on. There's a couple more things that I need you to be doing. Here are the known factors now, and hey, these problems look familiar, right? We've done these with polynomials before. So I want you to go ahead and complete the division, and you can always check it using the boxes. Everybody should be familiar with the boxes. So everybody should be able to do this, certainly with the boxes, and then hopefully the boxes help you create the long division problem. So if you need to, you can ask the sub to re-show the video of me completing that problem again. When you finish with these two problems right here, 1 and 2, I want you to go ahead and turn the page and do the missing sections here, because there's some missing numbers that you should be able to do them mentally. If you can, great. If not, then work them out and find out what the missing things are. That should take you to the rest of class, and yeah, I'll see you guys next time. Groover, out.